Lake Acraman in South Australia is Armageddon for the purist. No other meteorite impact on Earth has stamped the surrounding rocks with such an abiding, unequivocal geological record of collision, earthquake, wind, fire and tsunami, the giant waves formed by major Earth movements. The story it tells is elemental, without dying dinosaurs or even Bruce Willis to complicate its simple message of destruction. First, the numbers. About 590 million years ago, a rocky meteorite more than 4 kilometres across and travelling at around 90,000 kilometres an hour slammed into an area of red volcanic rock about 430 kilometres northwest of Adelaide. Within seconds, the meteorite vaporised in a ball of fire, carving out a crater about 4 kilometres deep and 40 kilometres in diameter, and spawning earthquakes fierce enough to raise 100-metre-high tsunamis in a shallow sea 300 kilometres away. Ancient, stable and unglaciated, the bedrock of Australia preserves some of the most photogenic impact craters in the world. Acraman is not one of them. 500 million years of erosion has taken its toll. A salt pan surrounded by low hills is all that remains to mark the site of the cataclysm. The true nature of the place dawned on geologist George Williams of Adelaide University in 1979. Gazing at a sheaf of newly acquired satellite images, he saw the small circular shape of Lake Acraman surrounded by a ring of faults and low scarps 40 kilometres across, and an outer ring twice this size. A year later, he made it to the site. On islands near the centre of the lake, Williams found bedrock shattered in a conical pattern that experts consider a sure sign of a meteorite impact. Except for a crater, which had long since eroded, the area was a textbook example of an impact site. In 1985, further intriguing evidence turned up. Vic Gostin, another Adelaide geologist, had been studying a thin band of fragmented red volcanic rock in 600-million-year-old shale in the Flinders Ranges, more than 300 kilometres east of Acraman. To his bewilderment, the volcanic chunks turned out to be 1 billion years older than the shale. Where had they come from? Comparing samples, Gostin and Williams found that their rocks were identical. The red rock in the Flinders Ranges had been blasted there from Acraman. Later, the same material turned up at sites 500 kilometres from Acraman. Everywhere, the bands of fragments showed the same structure. Coarse pebbles at the bottom, then a cocktail of silt and sand, then layers of increasingly fine sand, distorted on top into a wavy, scalloped pattern. These layers also show, step by step, how the meteorite transformed the floor of an ancient sea, hundreds of kilometres away, according to Malcolm Wallace of Melbourne University. First came the earthquake. Travelling at about 3 kilometres a second, shock waves arrived offshore within a minute or two of the collision, stirring up the water with clouds of silt as the seabed shook. Then shattered rock from the explosion arrived by air. Pebbles and boulders crashed into the water, reaching a depth of about 200 metres within a minute. One day they would become the lower band of the Flinders Rock. Sand took up to an hour to come to rest, finally bedding down with the silt that was also now settling on the sea floor, as the effects of the earthquake died away. This mixture would eventually form the next layer. About an hour after the meteorite's impact, huge waves rolled in, leaving the ripples on the surface that later hardened into rock. Clear as mud is not an oxymoron. In Acraman, the arid, timeless Australian outback has preserved the closest thing the Earth can boast to a perfect pockmark, the pinnacle of imperfection.